All right, so today we're talking about function operations. And by this lesson, this should be familiar to you guys, okay? You did it at some point in time, did do this in Algebra 2. But you guys are going to be able to perform operations and also find the domains, okay? Perform operations and find the domains. Composite functions we'll do on Friday. And so we're just doing function operations today, okay? So in your foldable, you have operations with different types of functions. You have adding functions, subtracting functions, multiplying functions, as well as dividing functions, okay? And you can see it one of these two ways. You can see it as your f and your g being added together of x, or you have f of x plus g of x. Subtracting the same way, multiplying. You could also see multiplying as f of x times g of x. And then also you have dividing functions. So f of x divided by g of x. These are your different operations with your functions. And it is just that simple, guys. Like literally, you take your two functions and you add them together and combine like terms. When subtraction, you have to be very careful. Whatever function you're subtracting, make sure that you distribute that negative over. Multiplying, you just multiply two functions. Dividing, we'll talk about that when we get to it, okay? So, let's take a look at examples. We got two examples. It says let f of x equal x minus 5 and g of x equals x squared minus 2x minus 15. When you're asked to add the functions, you are literally adding them together. That's x minus 5 plus x squared minus 2x minus 15. Order doesn't really matter when you're adding, but it's always good practice because if it was a different type of operation, then it really is going to matter. And then you combine like terms from here. Don't leave it like this. Combine like terms. Do you have any other x squares? No. Do you have any other x's? So what's x minus 2x? And do you have any other just constants? So what's that going to be? Minus 20. Yep. There you go. And that's it. Just make sure you combine your like terms correctly. Do not do, negative 5 minus negative 15 and put negative 10 or something, okay? So be careful with your signs. Double check. Subtracting. You are subtracting two functions, but be careful. Look at this. This says g minus f. So that means your g function is going to be first, and then you're going to subtract your f function. Now, when you subtract these other functions, go ahead and put it in parentheses. Because then that might help you when from making that one common error that students forget to make. When you're subtracting the entire function, what do you have to do to that negative? Distribute it. So this is going to actually end up being, I'm going to swing over here because I don't have that much space. I wrote too big. That's going to be a minus x plus a 5. Okay? Easy type of thing to do, but also easy to make some mistakes. Combine like terms. What's my final answer? Minus 10. So far, so good. Yes? Question? No. But, and that is the normal, but look at what we're asked to find. Mm-hmm. You gotta be careful. I got the exact same thing on my copy, and then I was like, crap, I had to rip it out of my book and move it. So just be careful. Make sure you do the right order. Okay? Multiplying. You're going to multiply the two functions together. That literally means x minus 5 times x squared minus 2x minus 15. Well, it actually only applies to binomials here. So when you have a binomial and trinomial, it's really called distribution. So you got to distribute. Okay? Can you guys do that on your own? Okay, I'm going to give you 1 minute to multiply these. Okay, let's see how well you did. So I'm going to multiply x to everything in the second bubble. What's x times x squared? Anybody? X cubed. X times a negative 2x. times a negative 15? Then I just do the negative 5. What's negative 5 times x squared? What's negative 5 times a negative 2x? And what's the negative 5 times a negative 15? And so then I just combine like terms the way I did in like a little linear fashion. You don't have to do this. I just do it. And so then it's x cubed minus 7x squared minus 5x plus 75. You guys get that? Questions? Division. We're going to divide f by g. And I'm going to swing over here, just for a little bit more space. F divided by g. Now normally, this will be as far as you can go, okay? But if you can factor any part of the top or the bottom, you want to do so, okay? So, can you factor the bottom? Yes, you can. Y'all were able to do domain. Y'all can factor the bottom. Can you factor the bottom for me real quick? So how does the bottom factor? X minus 5 and x plus 3. Now the reason why you want to do this is because if any part of the top and bottom can be factored, you want to do so because if you notice there's something in common with the top that's also in common at the bottom, which means they what? They cancel out. Which means you are left with what? What are you left with on the top? 1. A 1, and on the bottom you're left with an x plus 3. So this would be your final answer. Now the one thing with dividing though, when you're dividing functions and you end up with something at the bottom after you simplify, you always have to make sure you state if there are any restrictions. Because you can't plug in every possible number for x and get something that's defined, can you? What number is going to make this undefined? Negative 3. So it's going to be this, and you also have to add an x cannot equal negative 3. No matter when you're dividing, when you have functions you're dividing, you always have to state the restrictions as well. And there you go. Operations of your functions. Any questions? No, not yet. Let's loop it. Looping means I'm going to go back and draw on something that we've already talked about. What is the domain of the sum of these two functions? What's the domain of this? Say it. No. Let's say something different. No, that's 20. Thought I heard over here. All real numbers. If it's an x squared, what type of function is this?
Parabola.
And what's the domain of a quadratic? It's all reals. How do I write that in set notation? How do I write that in set notation? Aaliyah? X such that. Very good. And what do I need around this? Curly. Very good. What about here? What about subtracting? What is the domain of what I got when I subtracted the two functions? Shay, what is the domain for this one? It's the same thing. Can you write it in interval notation though? How do you represent all reals in interval notation? And what's around the infinities? Yep. Good stuff. Let's look at the multiplying one. When we multiply, we got this in the pink. Malaysia, what's the domain for the pink? Like after, like the final result. All real. Okay? In all honesty, guys, unless you have a fraction or a radical, that's the only time you're going to ever have restrictions on your domain. Just like before. Yes, ma'am?
Why don't you use that order for the first?
Just y'all doing set. This one here, you have to be careful, okay? Whenever you're doing domain for when you're dividing two functions, you always base it off of the original division, not what you got when you simplified it. Everybody understand that?
Yes.
It's always off the original division, because if you notice when we canceled out the x minus 5, there's still a restriction there. There's still something happening at that value. So you always base it off of the original thing before you canceled out. So this will be all real numbers except what? Negative 3 and 5. So when I write in the set builder, it's going to be x such that x does not equal negative 3, x does not equal 5, and what do I have to remember after this? X is the element of all real numbers. Whew. We wrote this in interval. It would have been negative infinity to negative 3, union negative 3 to 5, union 5 to infinity. That's what it would have been. I don't like all these U's. I prefer set.